to use the shapes off of this packet that we had in class. But first, can you shut the door, please, Brianne? Thank you. But I'm going to just draw these on here and draw an XY coordinate axis by myself. All right, so this first one, we're going to have point D, which is 6, 3. E, which is negative 3, 9.
Because you're my favorite teacher.
Thank you. F, which is negative 6, 3. And G, which is 3, negative 3. Okay. So when we graph these, all right, so we have D, which is 6, 3. We get a different color here. D, which is 6, 3, so 6, 3, this is D. E is negative 3, 9, so 2, 4, 6, 8, 9. F is negative 6, 2, 4, 6, positive 3. And G is 3, negative 3. I'm going to grab a straight edge so that these look nice. Let's get those graphed. All right, so the first thing I want to do, I want us to make a guess on what shape it is, and we'll see if we can verify that guess. Okay, so let's see, is it a triangle?
Yep.
For goodness sake, it's not a triangle. Okay, square?
No.
Okay, so what do you guys think?
Rectangle.
Okay, so we're going to guess a rectangle. You good with that, Brienne?
What?
Are you good with guessing that this is a rectangle?
Yeah.
Okay. All right, so how could we verify that it's a rectangle? If I look at this right here,
All 4 sides are 90 degrees.
the sides are perpendicular?
No.
Okay.
Or all angles are 90 degrees.
Okay, so let's verify that now. So they have to have opposite reciprocal slopes. So let's see, when I look at DG, I have to go up 2, 4, 6, right? So I go up 6 and over to the right 3, right? So the slope of DG is 6 over 3, which will reduce to 2 over 1. I'm going to say over 1 so that we can make sure we recognize that the opposite reciprocalness, okay? All right, so let's do EF, because we probably ought to make sure that those are the same. We have to go up 2, 4, 6, and over 3, right? So the slope of EF is the same. It's 6 over 3, which reduces to 2 over 1. All right, so now let's try FG, okay? So we go down how far? Yeah.
I'm getting 2 points on the bottom right. Like, I'm getting G and F in the same box.
All right, G is 3, negative 3, so you go over 3 and down 3, so that's where G is. And then F is negative 6, 3, so you have to go to the left and up 3. All right, so now for F, we go down 6, so that's negative 6, remember. And to the right, 2, 4, 6, 8, 9, right?
Then that's 3.
Okay, so the slope of FG is negative 6 over 9, which will reduce to what?
Oh, I did this one. Hold up. I have 9 over 6 because I went from GE. Or the never mind, that's GF. I went from
Well, if you went from G to F, you still have to remember that if you're going to the left, you are going a negative amount because you're moving.
Yeah, but I just had the 9 over 6.
Oh, okay. So now that will reduce if you divide by 3 to negative 2 thirds. Okay, let's do ED as well. So we have to go down 2, 4, 6, and over 2, 4, 6, 9, right?
Yeah, so it's the same.
So yeah, the ED is the same slope. The slope of ED is going to be negative 6 over 9, which is negative 2 over 3. Okay, so let's see. Are our slopes opposite reciprocals? We have 2 over 1 and negative 2 over 3. Are those opposite reciprocals?
The what?
Are these slopes opposite reciprocals?
No.
No. So is it a rectangle?
Does that have to? No, it's not.
Yeah, because the slopes have to be opposite reciprocals. Remember the A over B and negative B over A? So this is not a rectangle. Okay, so which of these can we rule out? We know it's not a rectangle. Is it a rhombus? Are all 4 sides congruent?
No.
Okay, is it a square?
No, because not all sides are perpendicular.
Good. So it's not neither of those, so what are we left with?
Parallelogram. Oh,
Parallelogram.
Yeah, that.
Yes, so it is a parallelogram. It is a parallelogram.
What's on the other side of E and F?
And do you see how we have those parallel slopes, though? Two
Yeah.
sets of parallel sides?
Mm-hmm. I walked by Miss Sylvester this morning. She said our class is gonna freak out on her because she said there's a quiz. So I hope she's kidding.
Guess you'll find out, won't you?
Yeah.
Okay. We'll do a triangle now.
Sure.
Okay, so we have point A, which is going to be -2, +2. Point B, which is going to be 8, 6. And point C, which is going to be 4, -4.
Is it triangles that we use the Pythagorean theorem on?
We could use the Pythagorean theorem on just about anything, to be honest. Because I could use the Pythagorean theorem up here to find out what these lengths are. Do you see these right triangles?
Oh yeah. Because we already have 2 of them.
Yep. Well, we have all 4 triangles here, so we could easily figure out what the length of all these 4 sides are.
Well, the last one's 9. You can already see that.
Well, you'd have to do 6 squared plus 9 squared is the square root of, and take the square root and find what ED is. And then these are going to be the same, right? Because they're the same. Okay, so now we're dealing down here. Okay, so point A, -2, +2. Point B, which is 8, 6, so 2, 4, 6, 8, and up 6, 2, 4, 6. And point C, which is 4, -4. All right, I'm going to draw these lines in with a straight edge. Oh, sorry. Didn't realize I wasn't showing. All right, so let's make our guess.
I think it's triangle.
Really? I think so too. Now we have to decide what type of triangle.
It's right. Isn't it?
Do you see any right angles?
Oh no, it's just a regular triangle.
So now we have to decide between these triangles. We have isosceles, scalene, equilateral, or right angle. Right triangle.
Well, it's not right.
It's not right.
I don't think we have all equal sides. The base looks smaller.
I would agree. The base does look smaller. AC looks smaller than these two sides. So what do you guys think?
I think it's isosceles.
Yeah.
Okay, isosceles. I hope I'm spelling that right. If not, I guess they can fire me. All right, so which sides do we need to verify that are the same?
Oh, never mind. I messed up my triangle. No, I think it's scaling. Here's my triangle with the difference.
Well, if we show that these two sides are different, we'll show that it's scalene. So isosceles or scalene. All right, so which two sides are relevant that we need to show are either congruent or not congruent?
A, B, and B, C.
A, B, and BC. So you can do this via distance formula or Pythagorean theorem by drawing in those right triangles. Which ones do you want to do?
Pythagorean theorem.
Okay, so let's draw these in. So A, we go up 4 and over 2, 4, 6, 8, 10, I think. Yeah.
So 4 squared, 10 squared equals
Yeah, so
square root.
AB squared equals 4 squared plus 10 squared. Okay, so that'll give me 16 and 100, right?
Yeah.
Which is 116. And what do I have to do now?
Square root of 116.
Yep, take the square root. So AB is going to equal something a little bit less than 11. The square root of 116 is 10.77. So I'm going to write that in, 10.77. Okay, so now for BC, we have to go over 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Do I go over 4 by C?
Uh-huh. So now, what do you guys think?
I think it's back to isosceles.
I think it's back to isosceles as well. Do you notice that these legs of these right triangles are congruent?
Mm-hmm.
So what is BC going to equal?
10.77.
Mm-hmm.
We need to do AC.
Yeah, let's do it. Let's do it. Okay. So AC, we go down 2, 4, 6, and over 2, 4, 6. So AC squared is going to be,
36 times 2.
so yeah, 6 squared plus 6 squared. And 36 times 2 is 72. So what do you have to do?
Square root of 72.
Square root it. And so that's going to equal, the square root of 72 be a little bit more than 8. 8.48. So now we know that this side is 8.48. So now we can say with confidence that this is an isosceles triangle.
A does kind of look like a right angle though.
This does look like a right angle, I agree. This one? Or this one?
We're like